The error code L0 in an air conditioner is usually related to a low voltage issue from the external power supply and can also be associated with problems in the inverter module located on the electronic board of the outdoor unit. The inverter module is responsible for controlling and supplying current and the speed of the inverter compressor of the unit. The L0 code can appear in 4 cases. Case 1. The error code L0 appears immediately after starting the outdoor unit. In this case, it is likely that the problem is in the inverter module. To diagnose it, follow these steps. A. Measure the resistance between the U, V, and W pins and between P and N in the inverter module. All resistances should be infinite. If any are not, the inverter module is damaged and must be replaced. B. When replacing the inverter module, apply a layer of thermally conductive silica gel on the PFC and IPM electronic modules. Case 2. The error code L0 appears immediately after starting the compressor. The cause may be that the U, V, W cables are not correctly connected. Take the following actions. A. Ensure that the inverter module cables are connected to the correct compressor terminals according to the compressor labels. B. Measure the electrical resistance between U, V, and W, and between P and N in the inverter module. If any of the resistances are not infinite, the inverter module must be replaced. C. Measure the resistances between the inverter compressor pins. Generally, they should be between 0.7 and 1.5 ohms between U, V, W, and infinite between each of U, V, W, and ground. If any resistance differs from these specifications, the compressor is not functioning correctly. Case 3. The L0 error appears after the compressor has been running for a period of time. Follow these steps to find the fault. A. Check the cleanliness of the heat exchanger or coil of the external unit. If it is not properly clean, adequate heat exchange is not generated, causing excess pressure and increasing current consumption, which can trigger the error code. B. Check the proper rotation of the outdoor unit fan. C. Use a clamp meter to measure the compressor current to see if it is normal. Case 4. The L0 error appears occasionally. A. The cause of the problem could be poor ventilation of the outdoor unit or cleanliness of the outdoor unit, causing the error to appear, especially on hotter days. To solve this, ensure there is sufficient space for the unit's ventilation. B. Emphasize checking electrical connections to look for loose contacts. In addition to the mentioned actions, you can perform the following actions. Now, let's focus on the electronic controller of the outdoor unit. Check if its indicator LEDs light up or blink. 9. If the LEDs light up or blink, it can indicate that the board is generating DC voltage, and it is advisable to focus on the IPM circuit, which is responsible for distributing this generated voltage. If no LEDs light up, it is advisable to focus the inspection on the PFC voltage generation circuit. 10. When the LEDs do not light up, to check the PFC circuit, ensure that the DC voltage appears within the board, especially the voltage at the output of the PFC rectifier bridge. When the equipment is powered by 110 volts AC after the rectifier bridge, the voltage should be around 150 volts DC, and when the equipment is powered by 220 volts AC after the rectifier bridge, it should be around 300 volts DC. 11. If the DC voltage after the rectifier bridge is correct, now, without energizing the board, check for electrical continuity between the input and output of the PFC circuit coil or reactor. 12. Check the correct resistance values present in the PFC circuit as well as the state of the diode, and, of course, visually inspect and test the capacitors with a capacitance meter in addition to checking for electrical continuity in the board tracks. 13. Check the condition of the IGBT transistor in the PFC circuit. Before checking the electrical status of the IPM, it is recommended to verify if the heat exchanger or fins are in the correct position and to check the condition of the thermal paste. This is important because loose fins will impede heat dissipation, increasing the temperature of the electronic module and generating the error code. To verify the IPM electronic module, follow these steps. 1. Disconnect the equipment from the power supply. Remember that capacitors can store current. Use a multimeter on the DC voltage scale to measure across the capacitors and ensure they are discharged. 2. Locate the IPM electronic circuit. The IPM electronic circuit is covered by heat dissipating fins. Its pins are connected via 3 independent tracks and an electrical connector to the 3 compressor pins. 3. Positive power supply. Identify the high voltage positive power supply of the IPM electronic circuit by tracing the positive track from the largest high voltage capacitors to the IPM electronic circuit. 4. Negative power supply. Identify the negative track from the capacitors to the IPM electronic circuit by tracing the negative track from the largest high voltage capacitors to the IPM electronic circuit. 5. Identify the output points U, V, W. These can be identified by following the tracks from the compressor connectors to the IPM electronic circuit. 6. Set the multimeter to the diode scale. 7. The IPM electronic circuit is internally composed of 6 IGBT transistors, each containing a diode that we will test. Let's start with the integrity test of the first 3 diodes. A. Place the black probe of the multimeter on the positive input of the IPM electronic circuit. B. Use the red probe to measure the points U, V, W. C. The minimum voltage activation values should be around 0.45 volts for each measurement. D. The measurement obtained between the negative supply and each pin, U, V, W, should yield practically the same reading. Let's proceed with the integrity test of the last 3 diodes. A. Place the red probe of the multimeter on the negative input of the IPM electronic circuit. B. Use the black probe to measure the points U, V, W. C. The minimum voltage activation values should be similar to those obtained previously. D. The measurement obtained between the negative supply and each pin, U, V, W, should yield practically the same reading.